All right, guys, it's been a while. Here's our very first video, our very first fundamental problem for dynamics. Okay, so welcome to the spring semester. Let's get right into it here. We're going to begin with kinematics. Okay, now kinematics, just in case you forgot, is the mathematics of motion. So it's how we describe what's happening when something's moving in a mathematical way. Of course, there's lots of ways to do that. Now, if we have a situation where we're looking at having constant acceleration, okay, that's pretty nice for us because that means our old friends are all available. All right, so that means we get to use this guy, okay, A delta T, and that of course is what we called Sam. All right, and then there's Bumblebee, VF squared, which is V initial squared plus 2A delta X. All right, so that's Bumblebee. And then finally we have Optimus Prime, okay? And Optimus Prime is the one that's the most versatile, all right, which is why we named it after the most powerful transformer that we could think of, okay? So we got V initial delta T plus 1/2 A delta T squared, okay? Now, I better write that down too. That's Optimus Prime, okay? Now, super important that you realize that we can only use those when we have a situation that is, oh, that was not the right button. When we have a situation that is constant acceleration, okay? And we're going to have lots of situations that are not, okay? And we're going to do some examples of that in this video series here too. But we're also going to do some like this one here, which are constant. So let's dive right into this question. We've got a car, it's moving along, it's got some initial speed here, 35. The brakes are applied and it's going to slow down to 10 in 15 seconds. Determine the constant deceleration of the car. Now, they don't give us anything to work with, okay? And so other than these raw numbers, so it's okay to assume in this case that we have constant acceleration, all right? So in other questions, there'll be some clues and I'll point those out along the way that we can know for sure, oh, this is a variable accel. Okay, but problem number one, constant acceleration. All right, so what we're given, all right, let's write it down here. We know that initially we're cruising along at 35 meters per second. And in the end, we're going to be down to 10 meters per second. Okay, so we should probably make a drawing here. It's going to help us out. All right, so we're here. We're at 35. And sometime and distance later, we are down to 10. Okay, now we don't know this distance, but we do know the amount of time is 15 seconds. Okay. And again, you know, this semester as we move along here, it's super important to make yourself a good illustration. You know, it doesn't have to be beautiful. It just has to work. Okay. So let's get into it here. I'm going to pick another color. That'll work. Okay. So we know two speeds. We know a time. So this one is just screaming at us to use Sam, okay? So let's start with Sam, V final, V initial plus A delta T. All right, now we know we're given these values here. We're trying to find A. Okay, so let's do a little bit of algebra. Rearrange this thing, V final minus V initial over our delta T, just like this, okay? Now let's plug our numbers in here. Our final was 10 meters per second. Our initial was 35 meters per second. And we're dividing by 15 seconds. Okay, so look what's happening with our units here. Grab another color. What's happening with our units is we got meters per second. We're divided by seconds. So we're going to get meters per second squared in that thing. Okay, so when we plug the numbers in on our calculator, all right, we're going to get negative. It's like 1.66666, a whole bunch of sixes, okay, per second squared. So if we put it into 3 sig figs, we're looking at this, 1.67 meters per second square. Okay, there we go. All right, now, so it doesn't get much more straightforward than that. Okay, take home points here to make sure you got is get the 3 main equations for kinematics back in your head. Sam, Bumblebee, Optimus Prime. Okay, just put them right, boom, you got to have them right here, boom. Okay, available to you. Remember to draw a good picture. That's going to help you out. All right, and then remember to put your units in there. Work with your units so you can see what's happening there correctly. Okay, there we go.